you're not looking like, you know, somebody can snap and be looking somehow. It's not exactly the person, but they resemble the person. So like I didn't really know what to think about it. But I just know, Sha, the message is from you. You understand? Hello and welcome. Today we're gonna be looking at chemistry. Yesterday we were supposed to have chemistry. I don't know why we had English yesterday. Like, it's incredible. We are supposed to have chemistry, but we had English. So good thing we are gonna switch the days. So today we are having chemistry today as against English that we should have today. But it's not still very bad. Not so bad. It's still in line. Okay. So this is the platform we are using, and educate Africans. That's what people are using to prepare for WAEC. Okay. Importantly, for those of us joining us today, we have a new mathematics that we are building. That's the one we'll be using henceforth. It's interesting. We're going to make sure that every error we had in the other one, that all those are corrected in this one. So this is the math we'll be using. You can check it out. We are still working on it. We are just new on it. We are working on it. And also all our lectures, we are going to be upgrading them. Want to make sure that they serve your need, they serve the purpose of sorting out your needs effectively. Okay. So let's start off for today. We are going to be looking at chemistry. Let's go down to chemistry immediately. We'll click on view all courses. Make sure whenever you're on this platform that you register as a student so that you can be able to effectively follow our classes. Okay, so I've clicked on that. I'll scroll down. And then I'll click on chemistry. Zimuzon, you wait for me to finish this class. I'm not taking time. Before you go, you wait for me to finish this class. I'm not taking time. Just 30 minutes. Anita. But you people, Anita, why is you and Zimozo? Why are you people going? Once it's 6 o'clock, you people don't run. But it's 6:30, we say it now. Sometimes if I will just be starting class, you people have already started. You just stand up and you're going already. What of me and Abraham that used to stay here till night? No, this thing you people are doing is not fair. Okay, welcome everybody. Introduction to chemistry. That's what we looked at the last time. Uses of chemistry, adverse effect carriers, nature of matter, elements, compounds, and mixture. That's where we stopped the last class. So today we're going to be looking at separation techniques. Separation technique. I laugh at my pronunciation. So we're going to be looking at separation technique. I wanted to click on it, but once it's not showing, I have to click on a row to get logged in and properly. Okay, so that is what we are moving fast. You can see We just started. Already we are in separation techniques. So in one class, we looked at introduction, carriers, nature, elements, compounds, and mixtures. We even gave an assignment and people did and submitted, which we used as our profile, our status for those that did excellently well in it. So these problems are good for you. These separations, they are good for you to know them. So please, please, and please, and please, you have to. So let's look at these separation techniques. Let's look at them. Now, separation techniques. Each constituent of a mixture still retains its individual properties. This helps to separate mixtures using physical properties. Now, constituents of every mixture, you can always separate them. If they are chemical compounds, you cannot separate chemical compounds. You cannot separate chemical compounds, but you can separate mixtures. So those techniques used in separating mixtures are known as separation techniques. Those physical changes, physical properties employed in separating mixtures are known as separation techniques. You need to know them, and you need to know what they are used to separate or what they are used in separating. So these are the separation techniques, and these are the things they are used in separating. You have to just take note of this. So each constituent of a mixture still retains its individual properties. This helps to separate mixtures using physical properties. So the properties that are utilized in separating mixtures are their physical properties. They are physical properties. That means properties like their boiling point, their melting point, their size, the sizes, the ability to evaporate. So those are the properties. Those are the properties utilized in separation. So let's take the various separation techniques and look at what and what we can use them to separate. What kind of matter, what kind of things can we use them in separating? What kind of substances can they be used in separating? So number one is what we call sieving. So in sieving, you separate solids of different size. You sieve to separate solids of different size. In fact, there is one major one that is not here. We call it hand picking. If you go and buy Nigerian rice, there are stones. You will see stone inside Nigerian rice, stone. So before you use your Nigerian rice, you must make sure that you use what's it called? Your plate. You take it up and down, make sure that there is a separation of the stone from the rice. Then you hand picking. You pick out the stone because there is difference in color and size of the stone and the rice. You can easily look at the rice. You're able to differentiate between them. Even when you touch the stone, is harder. So you can use properties like color and how a substance feel when you touch to even separate. So all those are also utilized in sieving. So in sieving, you put solids of different size. The smaller one, they go down, the other one are there. Or you can also sieve liquid from a solid, where the liquid just goes through the sieving material that you have, the sieve material, whereas the solids stay on top. So solids of different size you can do with sieving. So when you're taking out solids from liquid, you call that one filtration. But normal sieving is between solids of different size. Okay, so take note of these that whenever you want to use sieving, that it is for solids of different size. Now there is another way of separation known as magnetic separation. In magnetic separation, you separate magnetic solids from non-magnetic ones. So can you give me examples of magnetic solids vis-a-vis non-magnetic solids? Who can give me one example of a magnetic solid? So that when you bring a magnet close to it, it will magnet. Whereas the other things that are non-magnetic solid, they will stay back. So in that way, you can separate the magnetic solid from the non-magnetic ones by simply bringing a magnet close, because that magnet will attract the magnet that is a component in the mixture. So that what is remaining will be the non-magnet. Justin, can you give me an example of a substance that is magnetic?
Iron.
Iron, thank you, iron. Very simple.
Okay.
If you have iron in your mixture, once you bring a magnet close, that iron will be magnetized because iron is magnetic. Whereas the other things, if you are having something like this, my corn that I just finished eating, the corn will not be attracted, it will be there. Then we have decantation, filtration, and centrifugation. These three methods are used for insoluble solid from a liquid. A solid that cannot be dissolved in a liquid is known as insoluble solid. Things like sugar and salt, once you put them in water, they will dissolve, so they are soluble. But things like iron, you put an iron inside water, it will never dissolve, so that iron is insoluble. So if you're separating it from that liquid water, you can use decantation. In decantation, you understand, you just pour out, the water will go. Once you put it in a keg and pour, you are decanting the water, leaving the solid. You can also use filtration. If you put your sieve and pour the mixture of both the iron and the iron will stay on top, whereas the water will be filtrated down. So that is another way. Then if you use centrifugation, centrifugation is when you put tubes, then you continue to while them. All the solid things will go to the bottom of the tube, whereas the liquid things or the higher denser ones the lower denser ones will be at the top. So you cannot decant. So any of these three methods can be used to separate an insoluble solid from a liquid. Okay, now you can also use another method known as evaporation, crystallization, precipitation, and fractional crystallization. Any of these can be used to separate soluble solid from the solution. This time around, we talked about soluble. In the former one, we talked about insoluble from the liquid. This one is a soluble from the liquid. And any liquid that can dissolve something or dissolve something becomes a solution. So how do you separate this same solid again? This one is an insoluble solid, but this one is a soluble solid from a solution that is formed by being together with a liquid. So you can use evaporation. In evaporation, you just put your keg or your pot, then you put your combination of what is soluble, like now your sugar and your salt now. Then you continue boiling. So the sugar and salt, they were initially dissolved in the water, but as the water continues to evaporate up, they will come out and you see your sugar and your salt. If you continue to boil, you heat to a temperature above the temperature boiling point of the what's it called, the liquid. The liquid continues boil and starts going out, so remaining your soluble solid. You can also do crystallization, can also do that. Precipitation can do that. Fractional crystallization. Now, when you're considering soluble solid that you don't want to heat them so much, in evaporation, you have to continue heating until above the temperature it will go, above the boiling point, so that the liquid will evaporate finish. If the solid you're trying to get cannot withstand such high temperature, please use crystallization. In crystallization, you don't really need to heat at that very temperature. You just need to induce the crystallization. It will come out. They will separate. Also, precipitation doesn't need so much high temperature, but you have to know the chemical to put in to enable this precipitation. In fractional distillation, we are talking about a situation where you have soluble things, but their temperatures, their boiling points are very close together. So you have to use what we call fractional. It's a more discrete way of, sorry, we are talking about fractional crystallization. No, it's not fractional distillation. I was explaining fractional distillation. But fractional crystallization is also more discrete way of using crystallization. In evaporation, okay, we've talked about evaporation. Then, if you want to separate solvent from its solution, use distillation. You're separating this time around. It's not solid, though. It's not the solid. It's not the soluble solid. Or it's not the solute. It's not the solvent that you want to separate from solution. That means this solvent is in solution with other solvents. You use distillation. So take note. But if the solvents or the liquids that are miscible that you want to separate have very close boiling points, then use fractional distillation. So take note, distillation and fractional distillation, you're separating the liquid, that is the solvent, Whereas in the evaporation, precipitation, fractional crystallization, and all these other ones, you're separating the solid, not the liquid this time. If it is a soluble liquid, we are talking about evaporation, crystal precipitation, fractional distillation. But if it is an insoluble, we're talking about decantation, filtration, and centrifugation. Now, a separating funnel is used to separate immiscible liquids, liquids that cannot be mixed together. Very good example is oil and water can never mix together. So if you want to separate them, just use a simple separation funnel, because once you pour them, the water will go down, the oil will be off. So you just open up the tap, all the things down will go off. So you've separated them, immiscible. Or you're talking about fuel and water. All these things are immiscible. So the one with higher density will go down, and once you open the tap, it will go out first. Whereas the one with the lighter density will stay off. Now we'll talk about chromatography. Chromatography is used to separate solutes from a solution. And you know that we have the paper chromatography and the other chromatography. So you have to take note of all these that can be. Then another one that we did not take note here is sublimation. So take note, sublimation uses to separate substances that can sublime from the ones that cannot sublime. Okay. So those are the various separation techniques that we have. We have some quiz to help buttress this point. So we have some quiz here to help buttress this point. So you can check it out. Test for purity. The purity of a solid sample can best be determined by solid sample. So only a solid that can have boiling point is for liquids, because liquids boil, whereas melting point is for solid because solids melt. You have ice can melt. Liquid is water and it can boil. So these solids can change from solid to liquid by melting, whereas liquid can change from liquid to gas by boiling. So here you have conductivity, which is not a test for purity. Solubility is not a test for purity. You remember when we say test for purity, there are three tests for purity. You have the boiling point, the melting point, and the spot that can be made on a chromatograph for colored items. So know that we're talking about boiling point, melting point, and the spot on the chromatograph. So those are the tests for purity. Take note. This liquid that you're considering, the test for purity is boiling point. The solid that you're considering, the test for purity is melting point. Now, if it is a colored material, we're checking about whether it makes a precise spot where it should make on a chromatographic paper. So the assignment for this class is to check out this question number 1. Solve, explain it. The simple separation process. And it says the separation of oxygen from nitrogen by fractional distillation of air is possible because. So solve this and write this question exactly the way it is with the option, explain the answer, submit to the WhatsApp group. Okay, let's stop there. Thank you. God bless.